Let's say you're going up to buy something and it's on sale for 25% off. Okay. Well, how do you figure out what the cost of that item is going to be? Well, let's see. You might have a sale. Let's put it over here. You might have a sale function. And I know you're like, come on, Nelson, it's 25% off. I just multiply by 25, 0.25 and take that away from the cost. Like if it's a $10 item, 25% is going to be $2.50, right? So we're going to take $2.50 off of the $10 item. Well, I mean, there is a way to do that with a function. You could say you've got 0.75 is what you're going to pay for the item, right? So 75% of the item is going to be your sale cost, right? But that's not your total price. So you had a $10 item, you get 25% off, you're going to pay $7.50. You also have tax on that, right? So what's the tax function? Tax in our area is pretty close to 10%. Let's just call it 10%. And so what are you going to pay? You're going to pay 10% of the cost, right? But you got to add that 10% on to your the original cost. So like $7.50, that's 75 cents. You add 75 cents to the $7.50 and you're at $8.25, right? So I'm trying to come up with some easy numbers here to deal with. Like $10 is pretty easy to deal with, right? Oh, geez. So let's think for a second here. If we had, let me, doggone it, Nelson, come on. So let's say you had a tax function. Geez, that's really weird. What's this doing over here? Let's just get rid of that. So let's say you had a tax function and it's 1.1x. I said, what's up with the 1.1? Well, the 1 holds the price, like $7.50. The 0.1 takes 10% of the $7.50 and kind of adds them together, right? It's kind of like 1x plus 0.1x. Here's the 10%. Here's the original price, right? So this is really kind of adding complication that we don't really need. Hopefully you understand, or I'm making it clear that, 1.1 is going to calculate, the price after you've included tax, right? Well, let's see. We've got really a composite function going on here. You're going to first calculate how much the item costs after you, multiply by 0.75. Okay, so X stands for the original cost. And now we multiply by 0.75. But then you're going to multiply all of that by 1.1. So this is a composite function. We deal with composite functions all the time. We may not realize it, but we really do. This wouldn't require any special derivative rule, right? I mean, it's such a simple function. If we wanted to know f prime of x, okay, what I would have is just a power rule function, right? I got a 1 right here. I bring the 1 down. I reduce the power by 1. And the x, like a lot of people think about, the x goes away. So I'd have 1.1 times 0.75, right? Or you could multiply the 1.1 first by the 0.75, right? And so it's just a simple little power rule, and it ends up being 1.1 times 0.75, okay? Now, when do we need a special rule? Well, that's where, functions that are a little bit more complicated than polynomials come into play. Like you see this trig function right here. We don't have just the basic sine function. We've got the sine of 3x. So we've got what we call an inside function, which is the 3x. It's what you would evaluate first. If we're going to plug an angle in here, like 20 degrees, you'd first take 3 times 20 degrees and get 60 degrees. Then you would take the sine of that 60 degree angle, right? So this is the outside function. The outside is the function you would deal with second. The inside function is the function you evaluate first. So let's make that little note. Function evaluated first. And the outside one is the one you would do second. Okay, so it's the one after inside functions evaluated. Inside function. So you notice I'm not talking derivatives right now. I'm just talking about like order of operation, really, after inside functions evaluated. It's important to identify the inside and the outside function if we're going to use this new thing called the chain rule. Now, the chain rule is not going to happen until section 7. So let's make that little note. Chain rule doesn't really happen until section 3-7. So what's up with 3-6? They're trying to point out that a simple composite function like this one right here would not be something that we need a new rule for. We would just use the power rule for. But a more complicated composite function is definitely something we need to have a new rule for. We can't expand this. You know how or we can't distribute like I did up here. Like I could have just rewrote this function. Let me just say it one more time here. I could have just rewrote this function as 1.1 times 0.75. Should have done the arithmetic before I made this video, and I would look like I know what 1.1 times 0.75 is. It's what is it? Like 0.1 is going to be 0.075. So if I had add that to that, it's going to be like 0.825, I think, maybe something like that. Let's call it 0.825. So you'd have 0.825x. Now we just have the power rule, and the derivative comes out to be 0.825. All right, I hope I made it clear. You don't need a chain rule for this, but you're going to need one down here. So first of all, we need to know what the derivative of the sine function is. If we're going to mess around with, the outside function, well, we need to know more about the sine function. And we've already done that on Desmos once before. Let me just refresh your memory. What did we do? We went to Desmos. I'd like you to try this with me. And I'll attach this file to our Google Classroom today. But we put in there like the function f of x equals the sine x, right? Then on the next line, we did f prime of x. Now, you can see the two functions are on top of each other more or less. They're going through the x-axis, so it might be a little hard to see. And so what we did when we first did this activity is we add a vertical shift to this. So we said like plus 3, okay? So now we can see our sine functions up here, our cosine functions right there, right? Cosine starts at the high value and it goes down first, right? So the derivative of the sine function is the cosine function. And what this activity to do is on the next line, make some new function g of x, and we're going to call it the cosine function. And now you can see if I turn it on or off, you can see that they are the same, right? So they call it a conjecture, but man, I'm pretty darn sure that the derivative of the sine function is the cosine function. You might be saying, well, what happened to that 3? Remember, this is just a polynomial or a monomial, if you will. What's the power rule going to do to this 3? It's going to turn it into 0. So that's why the 3 went away for my derivative. But the sine function is not a polynomial. We're not applying the power rule. This is a new rule. And we're not going to really prove this rule until section 7. So that's another thing. We're going to have the chain rule, and we're going to have the proof of the sine function. Now, it's not something you have to be able to do on your own, the proof of the sine function. I'm going to show you how it works. But for now, I want you to feel pretty confident that the derivative of the sine function is the cosine function, okay? Let's do one more thing. Let me go to a cosine function. What's the derivative of the cosine function? So if I made this cosine of x, okay, so here's my cosine function up here. Hey, look at this function right here. The sine function starts at its neutral spot, and it would go up, not down. So what I want you to do is pause the video and make a conjecture. The derivative is definitely not the cosine function. What would be the derivative if we wanted a sine function that went down? So pause the video, you type it into line 3. All right, thanks for doing that. I hope you did. You're like, yeah, Nelson, I didn't do that. So I'm going to put a negative sine of x. I don't really need the parentheses, but let's test that out. Let me turn it on. Oh, yeah, for sure, right? So the derivative of the cosine function is negative sine, and the derivative of the sine function is just plain cosine. Those are two rules that I need in order to do today's homework. Now, before I finish my video off, I wanted to show you the book, and I wanted to show you some other homework problems here. So I'm turning over to page 102, and I want you to look at problem number 7. So you're going to state what the inside function is and what the outside function is. I got to warn you, I hope this one's pretty clear that 3x is the inside function and sine is the outside function. Okay, I hope that's clear. When the 3 is sitting right here next to the n, you could rewrite that. Let me go back to my notes where I can write something here a little bit easier. If you had a composite function like that, let's see what would make the most sense here. Let's actually put it right up here. Okay, so an example from our textbook here. Let's put down an example. Let's say you had some function and it was like the sine cubed of, I'm going to make it a little bit more complicated than the homework problem, of 5x. Okay. Well, let's see. I could rewrite that as the sine of 5x, and I could put parentheses or square brackets, if you will, to kind of make it a little bit clearer. So the sine of 5x cubed. Well, the cubed is the very last thing I'm going to evaluate if I'm like plugging a number in, like say 20 degrees. So I plug 20 degrees in for x. Okay, let's pretend like we're evaluating this thing. That's how you determine what's the inside function or what's the outside function. What's the one you're going to evaluate first is the inside function. The one you're going to evaluate next is the outside function. Now, this one I think has 3 functions really. So you do 5 times 20, right? After you got 100 degrees right here, then you would do sine of 100 degrees, right? So this is indicating that the inside function is the 5x, okay? This one's on the inside. The next one that we evaluated, I'll call it the middle function. Okay, so the sine would be the middle function because it's the second one we would evaluate. See, I'd take 20 degrees, I'd take 5 times 20, that's 100 degrees. Then I would take the sine of 100 degrees. Now I would cube it. So this one is the outside function. So think about it for a second. The outside function is a power function. So at some point when we take the derivative of a power function, we're going to just do the power rule, all right? When we take the derivative of the middle function, what's the derivative of the sine function? We just conjectured, I didn't do a proof of it, that it's cosine, right? And then we're back inside to a 5x function. What's the derivative of 5x? We're just back to a power rule function. So you're going to kind of shift gears. You're going to use one rule to calculate a certain function. You'll use a different rule to calculate a different function. And in section 7, we're going to try to make that super clear. So all we're trying to do is acknowledge that we're going to have composite functions and that we're going to need different rules at different times. So that's the main focus of section 6. I hope I made that clear. You're fantastic. I know you are. Don't beat yourself up if I'm not making this clear. Ask lots of questions, and we can do it. All right. So thanks.